Hello everyone, I am Kavya from GM University Data Science Branch. Team members are Trupti, Ramya and Chaitra. We are discussing on the subject of machine learning, and in this we are explaining on the code of linear regression and decision tree, and the code is like import pandas as PD. It imports the pandas library which is used for handling structured data in a tabular format, and from sklearn.linear model import linear regression. It imports the test train data splits, which is used to split the data into training and testing sets. From sklearn.linear model import linear regression. It imports the linear regression model from the sklearn library, which will be used for regression analysis. From sklearn.tree import decision tree regression. It imports the decision tree regression model, another regression model used for the prediction of based on the decision tree. From sklearn.metrics import mean squared error, and it measures the average squared difference between the actual and predicted values. R2 score measures the how well the model explains the variance in the data. Next, we will be creating a simple data, and the data is like data equal to experience of 1, 2, 3, 4, 5, 6, and so the number, some data set number will be given as experience and salary, and it creates the dictionary with the experience called it represents the year of work experience, and it is also known as independent variable, and the salary represents a corresponding to the experience, and it is a dependent variable. It converts the dictionary into a pandas data format, and here it is using pd.data frame, which organizes the data into a structured table. And next we will be defining the further part will be continued by Trupti.
I'm Trupti from the Data Science branch. I'm explaining about defined features and target. Here, x is equals to df double square bracket single quotes experience. It selects the experience column from the data frame as features. It means it is a independent variable. The double square bracket ensures that x remains a data frame rather than a series. Then y is equals to df single quotes salary column as the target variable. It means it is a dependent variable. Since we use a single brackets, y will be a series. And next, from the split the data set into training and testing data. X try, X test, Y test is equal to train test split of x comma y test size is equals to 0.2, random state is equals to 42. It splits the dataset into training and testing sets. X and Y are past inputs. Test size is equals to 0.2. Allocates 20 or 30% of the data for testing and 80 or 70% for a training data set. Random state is equals to 42. Ensures reproducibility. The functions returns four outputs: x and y train. It means the target variable is 80% or 70%. X test and y test, the testing set for a target variable is 30% or 20%. The next further part will be continued by Ramya.
Creating the decision tree model, DT model is equals to decision tree regression represents decision tree regressions the initial a decision tree regression model. Max depth minus 3 limits the depth of 3 to prevent the overfitting. A smaller depth makes the model simpler. Random state ensures that the results are reciprocal by fixing the random seeds. Training the model. Line 2 represents training the model. That means DT is equals to model fit. Fit represents training the model using training data as feature and a target value. The model learns pattern and relationship between input and output training. Line 3 represents making prediction. Predicts using the trained data target values. The result Y predict is an array of predicted values. Print decision tree. This prints the result asking for decision tree. Adds a new line for the better formatting. Decision tree regression, a label indicating the output belongs to this model. Finally, we calculate the displayed mean squared error that represents how much prediction values deactivates from the actual values. A lower MSE indicates the better model performance. When calculating R square score measures how well the model explains the variance in the data, the closer to 1 and the better of the fit data.
And the output of the code will be like this. The test data extracted could be something like experience is of 4 and 9, and the actual salary will be 14, 45 and 70. And for the linear regression, the output could be mean squared error will be the value will be 0.25, and the R2 score will be 0.998. And further, for the decision tree regression, the output will be mean squared error 0.5, and for the R2 square, the value will be 0.996. Thank you for
Thank
watching.
you.
Thank you
Thank
for
you for
watching.
watching.